All right, the next video here, homework 2, number 1, still in your Foundations of Math class. I've scanned it in so we can kind of see the problems, but again, if this is hard to read on the video, you should have this homework page in your binder. So, first ones here, we are using comparison symbols. We have the less than, the greater than, or the equal to. So, less than points to the left, if you think about it. The small end is pointing to the left, or if you thought about it like an arrow, less than. Greater than, again, points to the right, so the arrow's going to the direction to the right. So when I'm comparing, if I am comparing 6 to 65, I like to think about it as money. If I'm comparing $6 to $65, $6 would be less than $65. So my symbol in there, it's not writing where I want it to, but I'll write it there. My less than symbol should point at the smaller number. The small end by the small number, the big end by the big number. I'm going to again try to fix my board here. Got a tickle in my throat, excuse me. All right, now we'll see if it rates how I want it to. So here again, I'm going to compare 90 to 92. $90 would be less than $92. So again, I'm going to have the less than symbol. I'm going to write it over here so you can see which one I wrote, but small end by the small number. 534 compared to 99. $534, way better than having $99. So 534 is greater than 99. The greater than, again, the big end by the big number. 765 to 360. 765 is, again, greater than $360. It's more than 360. So I'm going to put my greater than symbol in there. So we have less than, greater than, greater than. I'm going to move the board here. Oops, maybe. Got to do it over here. There we go. Whoops. Oh, it wants to hop all the way to the next page. Here, we'll just put it right there. All right. So number 2, same thing. We're doing our comparisons. 75 compared to 73. $75 is greater than $73. 4 compared to 59. $4 would be less than $59. 101 compared to 64. 101 is bigger or greater than 64. And then 464 to 926. 464 is going to be less than 926. So again, the bigger end by the bigger number, you're pointing to the smaller one, but we would have greater, less, greater, less. Number 3. We are rounding. When you round a number, you want to first of all figure out what place you're rounding it to. This one says round to the nearest 10. So what I'm going to do is I'm going to underline the tens place. The 7 happens to be in the tens place. I have 2 options. I'm going to leave the number in front and the number in the tens place the same and make the last number a 0. So 570 is one of my options. Or my other option is I round the 7, which was in the tens place, up by 1, so 580. That's my 2 options if I'm rounding this number to the nearest 10. Is it closer to 570 or should I round it up to 580? Well, when I'm rounding, I then look at the number behind the tens place in this case. If the number is 4 or less, I leave it alone. I would leave that the 7. If the number is 5 or higher, I round it up to the nearest 10. 576 is closer to 580 than it is to 570. So when I'm rounding that to the nearest 10, 580 would be my answer. If I look at number 4, round 259 to the nearest 10, again, the 10 spot, the 5 is in there. So I either leave it with a 2, 5 and putting a 0 behind that. The front digit shouldn't change. Or do I round it up to 260, changing that tens digit up by 1? 259 is between 250 and 260. Which one is it closer to? Well, it's closer to 260 because there's a 9 behind that 5. I end up rounding it up to the bigger one, 260 would be my answer, rounding that to the nearest 10. So number 5, round 4,702 to the nearest 100. So again, I look at what's in the 100 spot, which is the 7. I'm going to leave the front numbers alone, change the rest to 0. So either I'm going to leave it at 4,700, or I round that up by 1 and make it 4,800, 1 in the 100 spot since I'm rounding in the hundreds. So do I leave it 4,700 or do I round it up to 4,800? Again, this number should be between these two values. Which one is it closest to? It's closest to the 4,700. But if I look at my rule, the 7 is in my 100 spot. It's followed by a 0. If it's 4 or less, I leave the 7 alone. And so 4,700 is where I would round that to. I would try to scroll that up, but I think if I do, it's going to hop me to the next page instead of where I want to be. So I'm going to leave that there. Hopefully you can see that okay. The next one, 5,736. Again, we're rounding it to the nearest 100. The 7 is in the 100 spot. So, do I leave it 5,700 or do I round it up to 5,800? I look, behind the 7 is a 3. Since that's 4 or less, I leave it alone instead of rounding up to the next bigger one. And so 5,700. 5,736 is closer to 5,700 than it is to 5,800. And 52,689 wants us to round that one to the nearest 1,000. The nearest 1,000 would be the 2. 2 is in the thousands. So I'm thinking, do I leave it 52,000? 52,000, rounding that to the thousands, or do I have to round it up to 53,000? Again, I'm going to look at the number behind that. It's a 6. Since 6 is 5 or higher, I end up rounding it up. And so 53,000 is where I'd round that off to. 52,689 is closer to 53,000 than it is to 52,000. So when you're rounding, look at the place that you want to round it off to. Round it to the nearest 10. Leave the numbers in front the same. Anything after, change to zeros. Then take that tens place, in this case, round it up by 1. Then decide, should I leave it at the 7 or do I round it up to an 8? I decide that by looking at the number right behind the 7. If it's 4 or less, I leave it alone. If it's 5 or higher, I round it up to the next bigger one. All right. All right, rounding to the next page here. We're still doing one more rounding here. Round it to the nearest 1,000. So again, I want to look to find what number's in the 1,000 spot. In this case, the 0 is in the 1,000 spot. So leave the front numbers alone, 5,030, change the rest to zeros. So do I leave it at 5,030 or do I round it up by 1 more in the 1,000 spot? So 5,031, right? Do I leave that a 0 or do I round it up to a 1? If I look, there's an 8 behind that 0. Since there's an 8 behind the 0, I end up rounding it up. And so 5,031 is what I have when I round that to the nearest 1,000. All right. Number 9. We are now going to do some estimating. So when they have you estimate, they don't want you just to add up the numbers and round them off. What they want you to do is round them off first and then add up those 1-digit numbers or whatever, 2-digit numbers, whatever you might have. We're going to estimate by first rounding each number to the nearest 100. So rounding this to the nearest 100, instead of 261, we would round that off to 300, right? 533, Since there's a 3 behind the 5, I'm going to leave that at just 500. Now on this one, 4 is in the 100 spot. There's a 4 behind it, so I'm going to leave that at 1400. So the 261 I round off to 300, 533 we round down to 500, and 1445 we also have to round down to 1400. Now I'm going to add those together. So I'm going to add my 3 plus my 5 plus my 14, which would give me 2,200 or 2,200. So when I added that, I did the 14 first was bigger. 14 plus 5 is 19, and then 19 plus 3 would give me 22. And so I get 2,200 is what I get when I estimate by rounding to the nearest hundred. So number 10, again, we're going to estimate by rounding to the nearest hundred again. So 182, there's a 1 in the 100 spot. Because it's followed by an 8, I have to round it up to 2. So 200. 395, again, there's a 3 in the 100 spot, but since it's followed by the 9, I got to round it up again. So 400. And 1,337, the 3 is in the 100 spot. Because it's followed by a 3, we're going to leave it alone. So 1,337, we're going to round off to 1,300. Again, I'm just going to take my numbers, ignoring the hundreds, and add those together. So 13 plus 4 would be 17, plus 2 would be 19, and so 1,900 would be my estimate. The next one looks like we have a subtraction. We are going to round each number to the nearest 1,000 in this case. So in my 1,000 spot here, I have an 8. Do I leave it at 58 or do I round it up to 59? Well, I look, there's a 9 behind there. I have to round that up by 1. And so 59,000. That almost looks like 59,000. Let me erase that and try writing again. 59,000. Minus, on this case, the 3 is in my 1,000 spot. It's followed by a 0, so we're going to leave it alone and leave that at 23,000. So what I'm thinking about here is I'm taking the 59 minus the 23. 59 minus 23, 9 minus 3 is 6, 5 minus 2 is 3, so I'm going to end up with 36,000 when I estimate my answer. The next one, again, we're doing another subtraction. We are going to round to the nearest 1,000. So in this case, the 7 is in the 1,000 spot. It's followed by a 2, so we're going to leave that at 97,000. We're subtracting on this one. The 5 is in the 1,000 spot. It's followed by a 4, so again, we're going to just leave that alone. 55,000. So now what we're thinking is we have to take the 97 minus the 55. The 97 minus the 55. If I subtract that, 7 minus 5 is 2, 9 minus 5 is 4, so I'm going to have 42,000 for my answer when I estimate it by rounding to the nearest 1,000. So when they have you estimate, you're going to round all your numbers off to whichever place value and then add those front numbers together, and then hundreds, of course, have 2 zeros, thousands have 3 zeros, and so forth and so on, and then you can estimate. All right. So on these ones here, these are a little weird. It tells you to rewrite it as a multiplication sequence. So when you add the same number together, you can shorten it up and make it into a multiplying problem. If I have 2 plus 2 plus 2 plus 2 plus 2, 1, 2, 3, 4, 5, there are 5 2's. So what I'm really doing is taking 2, which is my base number, times 5, because that's how many times I have it there on my list. So 2 plus 2 plus 2 plus 2 plus 2 is the same thing as having 2 times 5. They both equal 10. She only gives you one example of that one, but basically you're going to change this to whatever this number is, and then how many times do I have it in my list. Number 14, again, I wish I could scroll, but I think if I do, it's just going to hop me to the next page. So if I'm multiplying 1,000 by 4, 4 has a decimal behind it. It's a nice whole number. If I multiply that nice whole number by 1,000, what's going to happen is it's just going to add those zeros on there. When I multiply by 10, I would have 40. By 100, I would have 400. And by 1,000, I'm going to have 4,000. So if I take 1,000 times 4, I end up with 4,000. Number 15, same kind of thing. I start with the 5, and I'm multiplying it by a power of 10. If I multiplied by 10, I would have 50. By 100, I'd have 500, but since I'm multiplying by 1,000, I have 5,000. So 4 times 1,000 is 4,000, 5 times 1,000 is 5,000. Wish you would add a little different number there. All right. And move my page. Ooh, 15. Oh, we still had a couple extra problems hiding down there. Let me find them. Let me see if I scroll with my mouse, if I can get exactly where I need to be. So we did 15, but we have 16 and 17 left here. And again, just to remind you, on the ALEKS program, unless the calculator is active, they expect that you're actually doing this work pencil, paper, and not punching just stuff into your calculator. You want to be able to do it without your calculator. Number 16, a small theater had 8 rows of 26 chairs each. An extra 7 chairs have just been brought in. How many chairs are in the theater now? So if I start here, I'm going to do my work up here so you can see it. I have 8 rows. Each row has 26 chairs. So I'm going to take 8 times 26 to figure out how many chairs. Or because I'm multiplying, I'm going to put the 26 on top just because it's easier to multiply that way than putting the 8 on top. So 26 chairs, I have 8 rows if I multiply. 8 times 6 is 48. I'm going to carry my 4. 8 times 2 is 16, plus my 4 gives me 20. So I have 208 chairs in my 8 rows of 26 chairs. However, an extra 7 chairs have just been brought in. So now I have to add on that extra 7 chairs. How many chairs are in the theater now? Well, 208 plus 7. 8 plus 7 is 15. So 200, I don't know what I'm writing there. 215 chairs is how many I have altogether. Number 17. Number 17, again, I'm going to go up here and write, so I'm going to write my arrow up there so you can see where I'm at. The Kim family just bought 6 crates of eggs. Each crate had 12 eggs. The family already had 9 eggs in the refrigerator. How many eggs do they have now? So, each crate has 12 eggs. I have 6 crates. So if I take 6 times 12, I'm going to get the total number of eggs I have in my 6 crates. So 6 times 2 is 12, carry my 1. 6 times 1 is 6, plus 1 is 7. So if I have 6 crates with 12 eggs, that's 72 eggs. However, I already had 9 in my refrigerator, so I have 9 extra ones. So now I'm going to take my 72 and add my 9. Let's see if I add my 9 here. 2 plus 9 would give me 11, carry my 1, so I get 81 eggs that I have in my refrigerator. Might take me a couple days to eat that many. All right. 18. Number 18 has to do with your properties of addition. So, on these first ones, you have the associative property, the commutative property, and the identity property. The associative property, the order is the same on both sides. The parentheses are moved or around something different. The commutative property. The commutative property, the order is switched. And then we have the identity property. If I have the identity property, I'm adding 0. These are your adding properties. You have an additive identity property. You'll also get a multiplicative identity property. But what happens when you add 0 to something? If I take 3 plus 0, I'm still going to get the same answer, a 3. That's why they call it the identity property, because adding 0 doesn't change its value. So, want you to fill in the blanks so you can show the appropriate property. In this case, 9 plus what equals 9? Well, 9 plus 0 equals 9. Then you're going to choose that that's the identity property. The next one, you look at that and say, okay, it's got parentheses. If it has parentheses, it's probably the associative property, but let's just double check. If it's associative property, the order on both sides have to be the same. 2, 8, 3. So this would have to be 2, 8, 3. Notice here the parentheses are around the first 2. Over here they're moved. They're over around the second 2. So when you do the commutative property, or the associative property, when you do the associative property, the order has to stay the same. The parentheses are moved. So this one here is your associative property. If I said commutative property before, fix that in your mind. If you have parentheses, it's probably the associative property. Here's your commutative property. The commutative property is just when I change the order around. So what plus 9 is the same thing as 9 plus 3? Well, it'd have to be 3 plus 9 being the same as 9 plus 3. That's your commutative property where you change the order. So on number 19, they're going to give you those same 3 properties, have you fill in the blank at which one is most appropriate. So again on this one, 7 plus 8 is the same thing as 8 plus what? Well, 7 plus 8 is the same thing as 8 plus 7. Again, all we did is switch those numbers around, so that's my commutative property. The next one, 6 plus what number is 6? We know that 6 plus 0 is 6. Adding 0 is my identity property. And then the last one, there's the one with the parentheses. If you think about associative and association is a group, parentheses are grouping symbols. So the associative property has to have parentheses in it. But what we have to remember is the order has to be the same on both sides. 4 plus 2 plus 6. 4 plus 2 plus 6 then. Here the parentheses happen to be around the last 2, and then they moved them around the first 2. Associative property, the order is always the same. And so this one here, we're going to say is the associative property. All right, number 20 and 21, now we're doing the properties of multiplication. So the properties of multiplication, pretty much like the properties of addition for the associative and the commutative. Then you have your identity property, which is a little bit different, and then your 0 property, which you don't have for the addition one. So again, the associative property, the order is the same, the parentheses are moved. Commutative property, we change the order, switch them around. Now here's what's a little bit different here. For your identity property, this is the identity property of multiplication, is multiplying by 1. If I take 3 times 1, I end up with the same answer, which is 3. So for addition, the identity property is adding 0, but for multiplication, the identity property is multiplying by 1. Because with the identity property, you don't want to change the value of your number. And then the last one you have is the 0 property, and the 0 property is when you multiply by 0, multiply by 0, it's going to equal 0, right? Anything times 0 equals 0. So again, when you look at that list, the first one has parentheses. If it has parentheses, it's most likely your associative property. And if it's your associative property, the order has to be the same. 4 times 3 times 9, 4 times 3 times 9 then. Here the parentheses are around the last two, here they're around the first two. Associative property, the order has to be the same on both sides, the parentheses are moved. The next one is an example of your commutative property. If you look at that, 9 times what number equals 6 times 9? Well, 9 times 6 has to equal 6 times 9. That's your commutative property where I switch the order of my numbers around. The next one, a little bit trickier you have to see here. 5 times what equals 5? Well, we know 5 times 1 is equal to 5. And if we're multiplying by 1, that is my identity property. 5 times 1 equals 5. And the last one, 7 times what is 0? 7 times 0 has to be 0. So if I'm multiplying by 0 and getting an answer of 0, that is my 0 property. All right, I'm going to try scrolling down a little bit so we can see that last problem. Again, the bottom of the page, so we'll see how difficult it's going to be. Let me close my ink layer. There we go. So number 21, same thing. I look at that first one. The first one has parentheses. If it has parentheses, I probably know it's the associative property, or at least I think it's the associative property. And I look. My order has to be the same. So if I have 3 times 4 times 9, I would have to have 3 times 4 times 9. Parentheses around the second two, parentheses around the first two. Associative property, the parentheses are moved, but the order has to be the same. The next one, 1 times what equals 4? Well, we know that 1 times 4 equals 4. And if I'm looking at what times 1 times 4 equals 4, that's going to be my identity property because I'm taking something times the number 1. The next one, 4 times 9 equals 9 times what? 4 times 9 would equal 9 times 4. I switch the order around. 4 times 9 equals 9 times 4 is my commutative property. And the last one there, 8 times what number equals 0? Well, we know that if I take 8 times 0, I'm going to get 0. And so that's my 0 property. When I multiply something times 0, I get an answer of 0.